Our project will detail all entropy involved in a student taking a chemistry test, from the physical mechanical energy involved in the writing to the production of each individual instrument used in the process, including the pencil, paper, ink on the test, and the calculator. Some assumptions were made while doing the calculations in order to standardize the information, and this presentation will detail those assumptions. As taking tests is something us BCA students experience all too often, we felt that this project would give us a chance to look at it in an interesting way. When the recording goes beep, press the right arrow key to go to the next slide.
Part of the chemistry test is making sure you have a good pencil to use. The electroanalysis of the pencil can be split up into the graphite, wooden body, paint, and eraser, each with a very interesting path it follows. Beep. These are the thermodynamic values associated with writing, assuming the test taker uses all 51 minutes of the BCA class period. Beep. Most important about the pencil is the pencil lead. Pencil lead is made of a mixture of graphite, powder, clay, and water baked at a high temperature. Graphite is made of layers of carbon atoms which slide off easily when pressured. Beep. The end of the graphite's journey is when the BCMR receives the finished pencils from the pencil factory. Using delta G formation values, we can calculate delta G formation for the combustion of octane. Assuming that the truck has a mileage of 20 miles per gallon and internal temperature of 353 Kelvin, the process has these values if the BCMR is 100 miles from the pencil factory. Beep. Before this, strands of pencil lead are inserted into the hollow wooden pencil bodies. Assuming this takes 5 minutes, we have the following values at STP. Beep. Before this, the pencil lead mixture is extruded into long strands and baked at 1255 Kelvin. Assuming there are 100 kilograms of the mixture, there will be the following values. Beep. Previous to this, the ingredients are mixed in the desired ratios, resulting in the following thermodynamic values. Beep. Before this, the graphite and clay are transported on a cargo ship from China to America. Many products in the United States are made in China, so it's a good possibility that these pencils originated there. Assuming about 1.5 million gallons of fuel and about 12,000 mile journey and an internal temperature of 353 Kelvin, there are the following values. Beep. The origin of this process is at the graphite mines, where assuming an 8-hour workday and a 220-pound miner, there are the following values. To find these values, we assume that a person of the same size sawing would use the same amount of energy as a miner. So these values are based upon that. Beep. Here you can see a picture of a graphite mine. Beep. Pencil factories first cut out the lumber they received into slats. Then each slat is given a hollow center for the lead and finally cut into individual rods. Assuming this process takes 2 hours and is done at room temperature, there are the following values. Beep. For this to happen, the wood is transported from forest, and assuming a distance of 100 miles and a mileage of 20 miles per gallon, there will be the following values for the combustion of octane in the engine of the truck. Beep. This retroanalysis begins in the forest, where machines are used to cut down trees. Assuming 30 gallons of octane are used and there is an internal combustion temperature of 353 Kelvin, there are the following values. Beep. Pencil erasers are often known as plugs and are made of synthetic vulcanized styrene, butadiene. At the end of the process, the long eraser rivet is cut into small segments and attached to the ends of the pencils. Assuming this takes a minute for each pencil, there are the following values for STP. Since this process is rare, the thermodynamic values are based upon a similar process of slicing. Beep. The transport of the materials from the manufacturing plant to the pencil factory, assuming 20 miles per hour and a 100-mile trip, has the following values. Beep. In the manufacturing plant, the eraser material is extruded into a long strand. Assuming this takes an hour and is done at 313 Kelvin, that's the following data. Beep. The rubber is made by polymerizing styrene and butadiene. However, the values below are based upon a similar process of the copolymerization of styrene. Assuming these processes are identical and the polymerization is done with 40 kilograms of material, it has the following thermodynamic data. Beep. To the pencils of paint on the pencil body. The smooth paint layer keeps the wooden pencil from splintering the user and makes it more comfortable to hold. Beep. The last step in the painting process is the energy involved in painting the finished product. Assuming this takes about 30 minutes, it has the following data. Beep. Before this happens, the yellow pigment, resin, solvents, and additives are mixed. Assuming this process takes 30 minutes, it has these values. Beep. If the paint materials are transported at 20 miles per hour and is a 100-mile trip, The process has the following thermodynamic information.
One of the main factors in determining the total entropy change of taking a chemistry test is the creation and transportation of the physical paper in which the test is printed on. In order to do so, I first analyzed the trees from which the paper was ultimately created from. Beep. Trees grow to great heights as a result of the photosynthesis reactions found in their leaves. This reaction is fueled with great help from the solar energy provided by the sun. Beep. Once the trees grew to a sufficient height, they were harvested by harvesting equipment, a process which takes approximately 12 hours. The cutting and mulching of trees uses approximately 30 gallons of gasoline, and the total change in entropy for this process is over 10,000 kilojoules per Kelvin. Beep. Once the trees were harvested, the product was transported from the harvesting site to a manufacturing mill, a process which consumes approximately 5 gallons of gasoline and has a total entropy change of over 1700 kilojoules per Kelvin. Beep. Once the harvested wood product had reached the paper mill, the manufacturing process could begin. The paper making process is time honored and consists mainly of mixing the pulp and slurry from the harvested wood, followed by a rolling process. The first known use of paper is thought to be from the year 105 CE in China. The mixing of the paper slurry and pulp is a process which consumes approximately 1,000 kilojoules per hour, assuming that the mill's operating temperature was 25 degrees Celsius. This was determined based on the similar process of mixing a large vat of paint materials, a value which was easily obtained. Beep. Following the manufacturing of the paper, the product was transported from the mill, which is located in China, to the port in Port Newark Elizabeth Marine Terminal. This is a process which utilizes about 1.6 million gallons of fuel, as this is a transport over a distance of about 20,000 kilometers. Based on the relatively poor fuel efficiency of large transport ships, this process has a total change in entropy of about 7 million kilojoules per Kelvin. Beep. Once the paper has been transported from China to the port in New Jersey, it must be transported further to BCA Mart, a distance of approximately 24 kilometers. This process utilizes about 1.6 gallons of fuel for one transportation vehicle. The total entropy of this system of transportation from the port of New Jersey to Hackensack is about 2,400 kilojoules per Kelvin. Although paper is the most essential part of a chemistry test, ink is almost equally as essential, as it displays the questions in which a student will have to answer. The earliest known use of ink is thought to be during the 18th century BC in China, in which the Chinese mixed plant and animal dyes with graphite and water. Modern computer ink utilizes pigments, resins, solvents, and other additives in addition to water. Beep. The process to synthesize the computer ink is relatively simple, as it mainly consists of incorporating and mixing the ink components, a process which has the following thermodynamic values. Beep. Likewise, the ink must be shipped from the processing factory in China to the port in New Jersey, a process which has the following thermodynamic values. Beep. Lastly, the ink must be transported from the port to BCA Mart, a process which has the following thermodynamic values. Beep.
The calculator is an essential part of taking the chemistry test because the test taker needs to perform calculations. Beep. Assuming that the student will use the calculator for 26 minutes, the following values show the thermodynamics involved in both reading the screen and pushing the buttons. Beep. The first component we will explore is the plastic used to make the casing and the buttons of the calculator. Before plastic can be made into the form we know, petroleum must be extracted from the earth. Beep. At 873 Kelvin, the petroleum is then refined to a hydrocarbon. Beep. Then, the monomer ethylene must go through polymerization. Beep. After polymerization, the newly formed plastic is molded through the use of the injection molding method at 353 Kelvin. Beep. Then, the plastic parts must be cooled at 289 Kelvin. Beep. The final step is assembling the plastic parts using screws. Beep. Another main component of the calculator is the photovoltaic cell, which is used to convert photons into electricity for the calculator to operate. The cell is mostly composed of polycrystalline silicon because of its semiconducting properties, its low cost, and its ability to allow the photoelectric effect to take place. Beep. Before polycrystalline can be produced, the silicon must be purified at 2797 Kelvin. Beep. After purification, the silicon must be heated to its melting point of 1683 Kelvin for the doping process. Beep. Next, the molten silicon must be doped with boron in order to allow impurities, which will cause the silicon to act as a semiconductor. The doping process takes about 1 hour at 1173 Kelvin at a rate of 50 kilowatt hours per meter squared. Beep. The next step is casting the silicon at 298 Kelvin, a process similar to the injection molding process aforementioned. Beep. Now the silicon must be cut into wafers to allow the sunlight to pass through the photoelectric effect to occur. The wafers are produced with the use of laser cutting, which requires 60 kilowatt hours and 2 seconds to cut at the rate of 0.15 millimeters per second. Beep. The final step in producing a photovoltaic cell is attaching the wafers to the panel. Beep. The next and probably most vital part of the calculator is a microprocessor chip. Similar to the photovoltaic cell, beep. The chip is composed of polycrystalline silicon. Beep. Again, the silicon must be first purified. Beep. Next silicon must be melted. Beep. And then is doped with dopant. Beep. Then the silicon is cast into a mold. Beep. And cut into wafers. Beep. Now the wafers must be etched by dissolving the surface of the silicon wafer by using lasers, solvents, or electrons, allowing the unwanted materials in the silicon to be dissolved. Beep. The final step is to attach the transistors to the chip. Beep. 3.2 kilowatt hours per kilogram must be used in order to produce synthetic rubber. Assuming the calculator uses 950 grams of rubber, there are the following values. Beep. After the rubber is produced, it must be shaped. The membrane is cut out with a water jet using a pressure of 2 atmospheres at 328 Kelvin. Beep. For an LCD screen, first we will look at the production of the glass substrates. Most glasses are composed of silica, sodium carbonate, or calcium oxide, which is used to increase resistance or shine. They are melted together at 1873 Kelvin. Beep. Next, this molten mixture is flattened via the drawing process, where it is placed with melted tin. Beep. After drawing, glass is strengthened through an annealing process. Beep. Then, a layer of silicon dioxide is applied to the glass for alignment of electrodes. These electrodes, specifically those of indium tin oxide, are coated on the glass substrates. Beep. Next, both positive and negative masks of certain patterns are placed over the substrates, and UV light is directed on them. The negative mask is used after the positive one so that the positions of the glass match. Beep. Afterwards, the glass substrates must be coated with a polymer in order for the crystals to line correctly. Beep. A sealing resin must be applied to glass substrates. Since sealing the substrates with resin is similar to coating the glasses with a polymer, the same thermodynamic values are used. Beep. Now, the liquid crystals are injected between the glass substrates. Beep. To make the LCD more visible, polarizers are glued to the glass. Beep. Finally, the assembled LCD is attached to a circuit board. Beep. The lithium battery is composed of 4 main parts: an anode cup, a separator, a cathode, and a cathode can. Beep. The anode cup is the first layer of the lithium battery, which includes the lithium. Assuming that 0.015 kilograms of lithium are in this layer and 2.5 kilowatt hours are consumed per gram, there are the following values. Beep. The second layer is a separator, which is basically a salt that is soaked in a solvent or electrolyte to cause a separation between the anode and the cathode. In this particular battery, lithium salt is soaked in a solvent where electrolysis takes place. With the same pressure and amount of lithium, there are the following values. Beep. The third layer is the cathode, which in this case contains manganese oxide. Beep. The fourth layer is the cathode can, which contains a carbon layer. To produce this layer, we assume 40 kilowatt hours are needed that this process occurs at 298 Kelvin. Beep. Due to the fact that most calculators are produced in China, the products must be shipped from China to the US. Therefore, shipping has entropy infringement values shown here.
Taking a test on an empty stomach is never a good idea, especially when it comes to chemistry. Without proper nutrition, the brain does not operate at the proper efficiency level. So popular snack to consume before a big test is banana. which also makes you feel better, so you don't flip out as soon as you hit a problem you're flabbergasted by.
Beep.
The production of a banana begins on a small village farm a few miles away from Panama City, where a 10-foot wide banana tree sits alongside rows of others, absorbing the sunlight. A 10-foot wide tree has a surface area of approximately 80 square feet. The Earth's surface absorbs 11 zetajoules of energy every day, 1.1 times 10 to the 22nd power. The Earth's surface area is 5.5 petafeet squared, so each banana tree is being hit with 80 megajoules of solar radiation every day. But in Panama, the climate calls for about an hour or two of rain daily during the wet season, aka the growing season. This means that ultimately only 65 megajoules of sunlight actually get to the planet daily. Over the course of 3 months, the growing period, the total amount of solar energy that makes its way to the planet is 5.9 terajoules. But these values are for the entire planet. We are looking for information regarding only one banana. In each banana tree, there are between 3 and 20 tiers, and each tier has up to 20 bananas on it. Assuming that each tree has about 12 tiers and 18 bananas per tier, there are about 215 bananas on the tree. So the net energy applied to one banana is 28 megajoules over the growing period. However, photosynthesis only allows between 3 to 6% solar energy absorbance, meaning that between 840 and 1700 kilojoules are actually absorbed by the plant to create one banana. The change in entropy of the universe for the energy of sunlight hitting the planet is 78,000 kilojoules per Kelvin. The change in entropy for the energy that is actually used in photosynthesis is about 3.5 kilojoules per Kelvin.
Beep.
Great, we have a banana, but it's not in test taker's hand. It's in Panama. The majority of goods shipped across the world are shipped across the seas in huge cargo ships and those familiar big rectangular Lego-like boxes. Each one of those boxes can hold approximately 1,400 cubic feet, and each ship holds about 16,000 of those containers. One banana is about 3/100ths of a cubic foot. This means that one banana that a test taker will consume is 15 millionths of the total volume of the container ship. Each container ship travels at 25 knots, about 30 miles per hour, and burns 1/4 pound of ship fuel per horsepower per hour, while operating at 100,000 horsepower.
Beep.
At this rate, the 8,500-mile trip from Panama to the port in Elizabeth, New Jersey will be covered in about 280 hours. Over the course of the trip, 7 million pounds of marine fuel, number 6, will be burnt, and 140 terajoules of energy will be released. However, our banana is only 15 millionths of the 140 terajoules of energy required, so each banana transported requires 210 kilojoules. When it gets to Elizabeth, it still has to be transported to Hackensack. We chose Hackensack to be the destination because we're assuming it went to Target down the street, and our test taker is a bit of a rebel. Sorry, Dr. Crane, Mr. Lynch. The banana was transported to Target in a typical 18-wheeler semi, which gets about 6 to 8 miles per gallon. Being that the trip is only about 25 miles and each gallon of gasoline has the equivalent of 130 megajoules, the truck uses 460 megajoules of energy to transport it. However, one banana is only 81/100,000ths of a percent of the 4,000 cubic foot container, so the energy used to transport a banana from Elizabeth to Hackensack is approximately 4,000 joules. The net energy 4,000 kilojoules. The net energy used to transport a banana from Panama to Hackensack is 4,210 kilojoules. The change in entropy of the universe to transport one banana 8,500 miles is about 1,500 kilojoules per Kelvin.
Beep.
Humans are dynamic beings, and because of that, natural processes are continuously occurring within the body, meaning that energy is always being consumed. The basal metabolic rate is the energy required for your body to just be alive and perform all the internal functions. Basically, your body at rest. The equation used takes into account the weight, height, age, and athleticism of the individual. We could just throw in some numbers for simplicity's sake, but why not make numbers mean something? We chose to use one of your top chem students as a model, Jacob Drewinski. For one 180-pound, 5'10", 16-year-old athlete, the energy consumed in 1 hour is about 130 calories. 20% of that powers the electrical impulses in your brain. But when it undergoes extreme mental load, the energy consumed increases by 20 to 30%. So the net increase because of the stress is about 6 calories. Sitting down, writing, calculating, and doing quote-unquote desk work for a 185-pound male burns 80 calories per hour. So in total, for me to take the test would cost 216 calories, which is the equivalent of about 900 joules. Thus, the change in entropy in the universe for the energy used by the student is about 3,000ths of a kilojoule per Kelvin. Including all these materials and components necessary for the final act of taking a chemistry test, the final net change in the entropy of the universe is 2.92 times 10 to the 7th kilojoules per Kelvin. This value is positive, showing us that the total process is spontaneous. The factor which contributed most to this conclusion is the amount of octane and other fuel involved in the combustion reactions during the transportation of many of the materials. Originally, we had assumed that the total process would be non-spontaneous, as we had not taken into account the amount of transport necessary to make taking the chemistry test possible. We hope you now have a better understanding of the amount of energy and entropy involved in making this process possible. We know we have learned a lot. Thanks for watching.